Welcome back. So last lesson you learned about floating point normalization, and in this lesson we'll learn about floating point addition, and this is the last binary math skill that you will need to learn. There is one more lesson following this one, but it's a review and recap lesson, just going back over the things that we've learned before. So this is the last thing you will have to learn about binary maths all year. So in this lesson, we'll briefly recap how addition works just to kind of orient ourselves. We'll look at how we apply those principles to adding two floating point numbers, and we'll do a couple of worked examples. So when we add numbers, either decimal or binary numbers, we line up the points and then add the values in each position in each column. So for example, in this decimal addition, we line the two numbers up so that the points are aligned, and then we add down under each column. And it's the same with binary. So a binary addition, and we've added and carried within each column. So before we can add two numbers together, we have to line up the points, or in other words, make sure that each position value has the same meaning in both numbers. In floating point numbers, that means the two numbers must have the same exponent, because then all the positions have the same value. And the way we ensure that is we make the smaller exponent larger. So to summarize, to do floating point addition, we adjust one of the exponents. Specifically, we make the smaller exponent larger. We then have to make the mantissa smaller to preserve the number value. So we're going to do binary shift to make the mantissa smaller. And then once it's all adjusted, we just add the two mantissas together. So before we can add the mantissas, the exponents must be identical. So if they're different, we make the smaller exponent larger. We add to it. So this is the opposite of doing normalization. In normalization, we make the mantissa bigger and then subtract from the exponent. When we're doing addition, we add to the exponent and shift the mantissa to make it smaller. So let's look at a couple of examples. Supposing we had to add these two numbers, that would be a very typical question in the exam. And typically the floating point addition question, which generally comes up, if it comes up, it's usually the last of the binary questions. It's the most difficult of the topics. So we can straight away see that the exponents don't match. And the smaller one is 1 and the other one is 3. So to make them match, we've got to add 2 to that exponent. So we're going to increase the exponent and decrease the mantissa. So we're going to add 2 to the exponent, and that means we've got to shift the mantissa 2 to the right. We're making it smaller. Of course, that messes up the normalization, but that doesn't matter for now. So let's just go back over those rules again. Find the smaller exponent and make it bigger. Shift the mantissa to the right by that many places. However many you've added to the exponent, you shift the mantissa down that same number of places. Yes, it'll mess up your normalization, but that'll put itself right when you do the addition. So to prove it, here are our two numbers now. The top one has been adjusted so that the exponents match, and now we add the two mantissas together. The exponent doesn't change. And that's the answer to the sum, and you'll notice that it is in the normal form. It's correctly formatted. So when you change the exponent, you messed up the normalization, but that problem generally, or perhaps always, gets fixed at the addition stage. If at any point you end up with a number that's not normalized, and you would fix that using normalization. So let's try another. As you can see, the two numbers don't have the same exponent. One is the top one is -1 and the bottom one is +1. And for the purposes of this, we take a minus number to be smaller, so we have to adjust that by making it larger. We've got to increase it from -1 to +1. So obviously we've got to add 2 to the exponent. So here's the number that we start with. We're going to increase the exponent by 2, and we're going to shift the mantissa 2 to the right. And that's it. We've done that. Now we've got the numbers in with the same exponent, we add them together and we get that result, a normalized result. So I'm going to leave you with 2 practice exercises. I'm not going to show you the answers to these in this presentation. Next time we meet, we'll talk about that. So carry out both of those in your own time, and then we'll check and make sure that you've got them right. Binary addition, floating point addition is the last skill that you're going to have to learn. There is one more lesson, so that will just go back over the things that we've been learning for the last couple of weeks. And there's a mini mock in class next time we meet. So bye for now.